And now, for the problem you've all been waiting for. In this video, I will show you how to graph a tangent function with everything on it. You've got your reflection over the x-axis. You've got your a value. You've got your phase shift. You've got your vertical translation. It's got it all. Buckle up. Okay, first thing I see is this negative sign right here. That means that yes, we have ourselves a reflection. So that's going to be fun. Also, this is the A value, which is going to affect the stretch in a way, but we'll worry about that later. The B value would normally appear right here. Okay, the fact that there's no number sitting here means that the B value is 1, which tells us that the period is unchanged. So I'm going to go ahead and write that down because we really need the period. So the period is going to be pi because that is the normal period of the parent function of tangent. Okay, normally we have to do, for the period, we always do the normal period divided by the b value. But since the b value is 1, period is just pi. Now, we also have this h value here. All right, this is the first one of these that we've done. And that's going to be your phase shift. So please understand that this is moving in the opposite direction of what you would normally think. So this is a phase shift of positive pi over 2 to the right. All right, so it's the opposite of what you see here. So if it's minus pi over 2, you're actually going to be adding pi over 2. You're going to be moving pi over 2 to the right. If this was plus pi over 2, then I would go negative pi over 2 to the left for my phase shift. There's also a k value. All right, we call this the k value, and it controls vertical translation. So this is going to be a vertical translation of down 1. All right, because of that negative 1. I will do the vertical asymptotes at the end. All right, I like to graph it first. So, because of the phase shift, normally I start right at 0, and I put 0 right here in the middle. But I'm not going to do that this time. Because we have a phase shift of pi over 2 to the right, I am going to start with that phase shift. All right, you know how normally we have a point at 0. Well, the point that is normally at 0 will now be at pi over 2 because it will have moved pi over 2 to the right. So I'm going to put pi over 2 somewhere near the middle of my graph. And I'm going to use that to go off of. Let's see, I think I like to do this in gray. So because of the phase shift, that's why I'm starting at pi over 2. And so normally I would say, okay, my new point is right here. All right, this will be the center of my tangent function. And it's going to go from there, and it's going to be doing like this, and I would do everything else. But it's a little tricky because I can't do that yet because not only is there a phase shift, but there's also a vertical shift, a vertical translation. So this point is going to wind up moving up. All right, so I'll just leave the pi over 2 sitting here to remind us that this is going to be the new middle of my graph, if you will. So look, kind of step 1 of graphing when you have a phase shift is start with your phase shift in the middle of your graph. This will be helpful because you know the first point is going to go right there. The point that normally is at the origin is going to be at pi over 2 because of the shift. Now, rule number 2. Each one of these marks is 1/4 of the period. So we're just going to start adding 1/4 of the period over and over again to label these. So add 1/4 of the period repeatedly. Okay, so what do I mean by that? Well, the period is pi. So what is 1/4 of the period? All right, well, 1/4 of pi would just be pi over 4. Okay, so pi over 4 is 1/4 of the period. So that is what we're going to be adding repeatedly. So as I go to the right, every one of these marks should be increasing by by 1/4 of the period. So in this case, every mark should be increasing by pi over 4. So in this case, I'm going to be adding pi over 4 repeatedly. Okay, now the easiest way to add pi over 4 repeatedly is to have like denominators. So look at this pi over 2. Can you see that pi over 2, if I wanted it to have a denominator of 4, right, wouldn't I have to double it? So wouldn't this be the same thing as 2 pi over 4? Okay, so fine, this is 2 pi over 4. So imagine that I took 2 pi over 4 and I added 1 pi over 4. All right, because I'm adding 1 pi over 4 repeatedly. So if I took 2 pi over 4 and I added 1 pi over 4, wouldn't I have 3 pi over 4? Okay, so this is going to be 3 pi over 4. I'll go back and write it in gray in a moment. And if I kept going, if I added again, wouldn't that be 4 pi over 4? And wouldn't this be 5 pi over 4? Okay, I'm trying to get 1, 2, 3, 4 marks. So I'm going to do one more. Wouldn't this be 6 pi over 4? Okay, so I'm going to go back and reduce these, and I'm going to write them in gray so they all match. 3 pi over 4 can't be reduced, so I'll just write that down. 3 pi over 4. 4 pi over 4 is just pi. 5 pi over 4 can't be reduced. 6 pi over 4 is 3 pi over 2. So that's what I'll put down, is 3 pi over 2. You must reduce. You're not allowed to leave the numbers like these purple numbers. You have to reduce. Now, so these are the values that I'm going to use for one period of the function going to the right. All right, remember the pi over 2, that's the magic one that's right in the middle. Okay, now going to the left, I would be subtracting pi over 4 repeatedly, right? So imagine that I did that. Okay, so now I'm going to decrease by pi over 4 over and over again. So this is 2 pi over 4. So if I subtract pi over 4, wouldn't this be 1 pi over 4? Okay, if I subtract pi over 4 again, wouldn't this be 0? And if I subtract pi over 4 again, wouldn't this be negative pi over 4? And if I subtract pi over 4 again, wouldn't this be negative 2 pi over 4? Let's see, I want to go 1, 2, 3, 4 places to the left, so this is far enough. Now I'm going to switch back to gray and do any simplifying I need to do. So of course this is just pi over 4, and this is 0, and this is negative pi over 4. Now negative 2 pi over 4 is the same thing as negative pi over 2. Alright, so when there's a phase shift, it's a little trickier because these are not just the mirror images of these. So it takes a little bit more thought. but I think that's the most efficient way to do it. So now we have all of our critical values labeled on the x-axis. Okay. Because there is a vertical shift, okay, things are going to have to move down 1. I really need my y-axis in here now. So the y-axis always goes at 0. So even though it's no longer going to be the center of my graph, all right, the center of my graph is, don't forget, is here at pi over 2. I need the y-axis to stay at 0. So I'm going to just erase these purple points and put my y-axis in. All right, so there's my y-axis, and so I know I'm going to have this vertical shift of -1. So what I need to do is I need to show -1 so I can put a dotted line for my new midline. Now I'm going to space this out pretty far though. I'm going to put my -1 way down here, further than probably I normally would. Okay, so if this is -1, then spacing equally out, this would be -2. The reason why I'm spacing it out further than normal is because I'm trying to look ahead, and I'm looking at this a value. That's going to give me the stretch. So because this is 1/2, all right, ignoring the negative sign, because this is 1/2, I know that I'm going to have to be going 1/2 above and below the midline, and that's going to be a critical value. So I want to leave space to be going 1/2 above and below without squeezing it in too much. That's why I spread it out so far. Okay, the midline is going to be at -1 because of that vertical shift of down 1, because of that -1. So I'm going to go ahead and draw my midline as a dotted line. So I'm going to treat this the same way as I treated my x-axis previously. So it's finally time to put some actual dots representing points on this graph. Now please remember, pi over 2. All right, let's not forget step number 1. We started with the phase shift right in the middle of the graph, and our phase shift was pi over 2. So that's why this is right in the middle of the graph. So there should be a point on the midline right in the middle of a tangent graph. So I'm going to go ahead and put a point now, but this is the point that normally would be on the x-axis, but it's going to be on the midline. Okay. Now that should repeat every time you go the distance of a single period. So this was right in the middle. So remember, every one of these marks was 1/4 of the period. That's why I carefully counted over 1, 2, 3, 4. This should be 1 period to the right. Okay, it will the tangent function will begin and end on the midline. So I'm counting 4 to the right, and I will count 4 to the left. So here I am on the midline, and I'm going 1, 2, 3, 4. So I should hit the midline again over here. Okay, now there will be vertical asymptotes halfway in between these points. All right, so there should be a vertical asymptote here at pi, and there should be a vertical asymptote here. Well, it's actually the y-axis. That's pretty funny. So I'm going to go ahead and put those vertical asymptotes in. All right, so here are my vertical asymptotes right here in between, right in the center of the period on the right and in the center of the period on the left. I made this one orange so you could have a hope at seeing it, even though it's right over the top of the y-axis. Okay, now it's almost time to draw the actual function. But please remember another critical thing. We have a reflection, all right, a reflection over the x-axis. So whatever would normally be happening, it's going to be upside down. So normally the tangent function is always increasing. So normally I would start at any one of these values at the midline and I would go up. But because it is a reflection over the x-axis, it should be going down. Okay, so I'm going to try to be very careful to make sure I'm heading the opposite direction. So tangent upside down is always decreasing. So if I start from this point, I'm going to be definitely decreasing my way. Now, one more thing as I go, let's think about the a value. The a value is 1/2 if you ignore the negative sign. The significance of that is halfway in between this point and the asymptote, that's how far above or below the midline it should be. So remember, this is upside down. I know it's a lot to remember. So it's decreasing, but right here in the middle, it should be it should be half of a unit below. So I'm going to go ahead and put a dot right there. And so now I can go ahead and draw it. So because it's upside down, the tangent function is going to be decreasing as it approaches the asymptote. So that branch should look very much like that. Okay, now I'm going to jump to the other side of the asymptote. And again, because it's reflected over the x-axis, instead of increasing, I am decreasing. So I'm going to start off high and I'm going to be decreasing. Now I'm keeping that a value in mind. So right here in the middle, I should be half a space above. And again, the reason why I'm saying half is because the a value is 1/2. Well, the absolute value of the a value. So there you go. Similarly, on the other side, all right, right here in the middle, it should be half of a space below the midline. So it should be here. So now I'm ready to draw that. So it's going to start off high, and because it was a reflection over the x-axis, it should be decreasing, decreasing, and I hope you will forgive my squiggly lines. This is really tough to do with an electronic pen. All right, but it should look very much like that, only smoother if you can do it. And finally, this last branch over here again should be decreasing. So I'm going to have to jump up high, and it's going to be coming down this way. But again, I need that extra value right here in between, which should be halfway. All right, because the a value is 1/2, it should be half a unit above the midline. And I know because it's falling, so I know it'll be above right here. And so now I can draw it. All right, so coming from the asymptote, it should be falling, falling, and falling. And that's it. Man, okay, that was the toughest graph ever. But that is what the graph should look like with a phase shift and a vertical translation and a strange fractional a value. It had everything going on. Everything except the only thing normal about this graph was the period. It had a regular period of pi. So the only thing we have to still do is we need to mention the vertical asymptotes. So we have two vertical asymptotes showing. We have one at 0, and then we have one at pi. Okay, those are the vertical asymptotes that we have showing. So let's go ahead and write those down. So we have a vertical asymptote at x equals 0. Okay, and we have a vertical asymptote at x equals pi. All right, because of the phase shift, I can't do my usual odd multiples of half of the period like I normally do. So just look what's happening. We have a vertical asymptote at 0, and the next one's at pi. Now, because of the period is pi, everything repeats every time you go a distance of pi along the x-axis. So if I go another pi, I'm going to have another vertical asymptote. If I go another pi, I'm going to have another vertical asymptote. So if I go pi to the right from here, where will I be? Well, if I add pi to pi, I'm going to be at 2 pi. Okay, so I'm going to have another asymptote at 2 pi. And then if I kept going, I'd have another asymptote at 3 pi, and 4 pi, and 5 pi. So we only need one more, but just understand that we are adding pi. Okay, so that's why it's going to be 2 pi. All right, and if I added pi again, it would be 3 pi, and so on. And that is going to do it for problem number 7, the most complicated problem that we've graphed so far. I look forward to doing another one of those.